Hi, I'm Aria.
And I'm Ella.
And today we're talking about the Coriolis effect and weather.
The Coriolis effect is based on the theories of George Hadley and Edmund Halley. They set the basis for atmospheric theories behind most common phenomena, like Hadley cell circulation and hot air rising at the equator and falling in the Arctic. This is the basis for the discovery of the three cells: the Hadley cell from 0 to 30, the Faro cell from 30 to 60, and the polar cell from 60 to 90. The reason there is three is because of the Coriolis effect. Earth is round, and therefore while we spin, the rate of rotation is different depending where you are. The pole is spinning at around 0 miles per hour, while the center is moving around 1,000 miles per hour. Air or wind in the atmosphere will retain its own motion in its latitude, and when moving from the equator, will appear to deflect right in the northern hemisphere and left in the southern hemisphere.
Atmospheric chemistry is what drives the Coriolis effect. Atmospheric chemistry is the chemical composition of the atmosphere, oxygen, carbon, all that stuff. It is also the movement of air around the atmosphere, as well as how air reacts in certain locations, as the latitude or longitude changes. The study of it also gives us the data to support the weather phenomena theories that Hadley and Halley had.
The Coriolis effect and Faro cell circulation are crucial to our weather systems and the heating of the Earth. It's the same reason why hurricanes spin in different directions in the hemisphere. The Coriolis effect is also the reason that many prevailing wind patterns exist, such as the North American jet stream. However, Faro cell circulation is still important. Convection circulates air on the Earth, resulting in the cells. And without the cells, the abundance of heat in the equator, due to it being tilted towards the sun, would be stuck at the equator. The cells allow the heat to be pushed towards the poles, allowing the temperature over the entire Earth to be more stable, which allows for more stable weather.
Coming off of the weather, a part that we haven't covered much of yet is the addition of carbon into the atmosphere. Carbon generally moves through the Earth and the atmosphere through the carbon cycle, a cycle of being pushed into the atmosphere through respiration and being pulled back down through photosynthesis. There are more facets to this, but these are the big ones. Right now, the amount of carbon being put into the atmosphere, by human sources mainly, is exceeding the amount the Earth can pull back down, leaving a lot of it trapped in the atmosphere. This is leading to more heat also being trapped in the atmosphere because it's a greenhouse gas, and this is resulting in an uptick of temperatures, which then results in changes of wind, its path, how it works, which affects weather phenomena.